Thank you so much. I'm going to make this really quick so that I can get through all my slides. So I'm with Forest Intelligence, and with any luck, you're now able to see my screen. Having adopted the traditional presentations with PowerPoint. Are you able to see Forest Intelligence in big white letters on my screen? All successful?
Yep.
Great. So Forest Intelligence is, we specialize in satellite services. So I'm going to keep using satellite to stress the kind of capability that's there because it's brilliant. It's kind of global, and it means that we can kind of provide really consistent information, and we can provide geospatial data and intelligence and products in a standardized form. That means we can kind of feed into different all other services in a very standard way, and it's also this huge coverage that we can obtain. So I'll quickly run through my intro slides. But why space? Because satellites are objective, so they're credible. You can't fake those results. They're repeatable, and we can actually dive back in time as well as forward. So if we find our new problem back in time, see the problem and see how it's motion through time rather than just focusing on here and now and into the future. And then it also helps us identify that kind of data gap as well at that macro scale. So without further ado, I'm going to dive straight in. So the kind of products that we offer at the minute and the algorithms that we focused on, which is what I really want to talk about, is the air quality, having a look at all of the different kind of inputs into the models themselves and what can we actually access from space to integrate straight into these models. And there's satellites out there to do that, but there's also all of the kind of gain that we can have from just kind of Google Earth imagery satellites, but really utilizing that imagery rather than just displaying it. And it's kind of a similar thing with congestion, understanding the movement of traffic. We can look at heat using infrared wavelengths from satellite. We can get land cover using the various green wavelengths in satellites and having a look at that spectral reflectance and that kind of seasonality and changing through the years, but also kind of the impact of climate change, for instance. And then we've also got things like the coastal zone. How is flooding affecting these areas? How might it in the future? What has it done in the past? And then also kind of a risk associated with that coastal area. We hear about the insurance claims in California, and it's kind of trying to quantify those and also provide, again, that data gap that just doesn't exist in a huge swathe of the earth. And so that then inputs into all of these other things: health, agriculture, urban planning, and the environment. So what I really want to talk about is just that kind of amazingness that satellites give us. So we all know what RGB imagery is, kind of normal standard images that we see every day whenever we look at maps. But then those images are actually made up of loads of wavelengths. So we're able to then play with all of the kind of, our photon comes from the sun, it hits our stuff, it bounces back. We have a different wavelength that bounces back. We can read that and understand it as what it really is. And so in this bottom image here, you can kind of see the movement of cars. So you can kind of identify that car that you're looking at, but you can also see which direction it's traveling in, because when we collect one image, say the blue band, you can see that that's first, and then it's moving towards yellow. So you can see what direction that car is traveling in, as well as the speed by going center of blue blob, center of yellow blob direction. So you can actually get a vector out of it, and we can understand loads of information across entire cities and across entire countries using those kind of algorithms. And we can get specific satellite imagery. We can task satellites to collect that and to collect it with very specific parameters that are optimized to our algorithms, and that's just kind of iteratively completed. So there's loads and loads of data that we can get out of this. So we can find every car in London and see how that changes throughout the week, months, years, and kind of get that congestion log to help with big scale planning, but also looking at noise. How can we reduce that? And all of that data can be provided in a really standardized way. And so it's really interesting and really quite fun. So one of the ways, I'll stick with a traffic example for now, but one of the ways we do this is using kind of machine learning techniques. There's huge databases out there, amongst others, XView kind of data sets. And so these have identified with these red cars, or green trucks, or orange the buses. And so we can train on all of those data sets. And then you can kind of see what the models that we've used in the frameworks that we've used here have kind of run through and found their boxes and then orientate themselves so that we can get a really accurate, small, big, or very big vehicle. And then from that, we can input that kind of data into an air quality model. So if 50% of London's air quality kind of negatives are coming from vehicles, then we can understand all of that data in one. And from that, we can kind of attribute it to death or risk of death, based on loads of other research that's available. But really what we're doing is we're inputting that raw data to allow the analysis in that standardized way, that reliable way, and providing just loads of information to be able to create good statistics that can go into these models. And this can then be repeated. So we're working, London was the immediate example, but then we dive throughout 20 countries in the UK, moving into Europe, looking at the Middle East, and looking at India to try and understand what impact all of these cars are going to have. And then what happens when we move to electric vehicles, where should these ultra low emission zones be, and trying to kind of apply that knowledge and kind of come in from here's the uncertainties, here's the input data and the good and the bad that comes with it. And then we're kind of entering the world at the moment of what's the best way to distribute this data. At the moment, we've been really quite technical with how we've delivered that data, normally in like quite an inefficient format. And now we're kind of thinking, well, what is the best API? What are the best portals? What is a mobile app a suitable metric for this? And I think that's what I've really loved about being more involved in Bristech, is understanding those kind of variables and learning that. And all input that I can get is so helpful. I haven't kept track of my time, but I can stop there unless people do want me to continue. If nobody says anything, I'm just going to keep going.
Okay. I think we probably need to stop. Thank you so much.
Sure.
Unless anyone.
Absolutely.
Did everyone? I'm going to unmute everybody. See if I can do that. Unmute all. I can't remember how to do it now. Can everybody unmute themselves? Ah, there we are. Mute all. Everyone's unmuted. Are they? I have to mute all first, I guess, before. I'm going to unmute everybody so that you can all. I think I can't figure out how to do it. Chris, are you able to do it? Just so everyone can give a quick round of applause to Johnny.
There we go. Did that work?
I think it did.